All right, welcome to the law of sines. It is really kind of powerful formula to use when we're trying to figure out sides and angles of triangles. It is trig, but this time it is not using right triangles, and we'll see how we kind of expand into that. So we're creating a right triangle from a triangle that's not one. It's a lot of fun here, so let's see what happens. So given triangle DEF, over here on the right, we have 22-degree angle, 91-degree angle, so obviously not right triangle. We have the two sides, 16.5, 6.74. And how would we be able to find the length of this side DE? Right now, we don't have enough. We're kind of stuck. So what we actually need to do is create right triangles, and we do that by dropping an altitude, okay? So one way to do it is I have this side already. Put this. We're going to drop an altitude here to DE. So we drop an altitude this way. I was seeing if we could drop one, like for example, from here to here, but we're not going to have any side lengths at that point, so we're going to get kind of stuck. So what we're going to do here now is we have these two pieces. We have this piece X, and we'll call this piece Y from, let's say, DEF. We'll call this the G, point G, right, where the altitude hits. So GE and then DG, we want to figure out those two lengths, and we just add them together, essentially, right? So what we want to do now is figure out these angle measures. So for example, if this is 22 and 90, then I know I can figure out by just doing 180 minus 22 plus 90, and I can just solve that way. So 90 plus 22 is 112, so we just do 180 minus 112, and we're left with 68. So we know that this is 68 degrees, and this other piece adds to 91 to 68. So if we subtract these guys, we're left with 23. And so now, if I use what I already have, okay, to figure out this point and this point, the 68 and 23, we can get it. So we're going to use sine here. The reason is because there's the law of sine, so we'll just see how this works. So if I do, for example, with x, and I do the sine, so opposite from 68 is x, so the sine of 68 is x over 16.55, cross multiply, and x is going to equal 16.55 times the sine of 68. And on the other side of things over here, if we do the same thing, we can use the sine of 23 is equal to y over 6.74. I can cross multiply, so 6.74 is times the sine of 23 is equal to y, and then we'll just add these two things together. And we can get this length and that length. So that's how we'd have to do this for every single one of these things. And it gets a little tedious. So we don't want to do that anymore. And so what we can use for this is the law of sines. So what the law of sines says is that the ratio of the sine of any angle to the opposite side is always the same when you pair any sides and angles that are across each other. Now, in a triangle, if we have angle A here, side A gets a lowercase letter, and it's always across from that angle. Okay, so with angle C, side C is across here, and with angle B, side B is across from it. So really all we're saying is that the ratio of an angle, the sine of the angle to the opposite side, corresponding side, right? And there's two pairs of those have to be equal. Okay? Even though there's three fractions here, we're only going to use two at a time. So it's either like A over sine A, C over C, B over sine B, C over sine C, so on and so forth. So let's see if we could use that formula with this original triangle, and let's see if it'll work. So here's kind of what the triangle looked like. We had 22, we had 91. I was looking for this. Okay, we'll call, just so you can see, it doesn't matter what the letters are. We'll call this Z. Actually, we won't. If this is F, we'll call this lowercase f, right? D, this is lowercase d. This is 6.74. And then we have 16.55 with E and nothing across from it. So what two sides and angles do I have? Well, if you look, I have F and that 91-degree angle here, and I have the 6.74 and the 22. So we're going to pair those up. So I have D, lowercase d, F, lowercase f. So we're going to do F over the sine of F, even though it's not A, that's fine. And then D over the sine of D. By the way, this works also if you flip these over. So if I did the sine of F over side F, the sine of angle D over side D, it would also work. And I plug in. So we do the sine of F, so the sine of, well, F is F over the sine of 91 is equal to D, which is 6.74 over the sine of 22. And then we just cross multiply. Now, some of you guys are saying, yeah, the sine of 91, I know what that is. I type it on my calculator, right? Sine 91, hit enter, and I get this thing. Now, I don't know about you, but remember, part of Common Core is being able to be accurate with your numbers. And so we should not be rounding this. We should not be saying, well, this is just 1, because it's not, and it's going to come off differently if you round it to 1. You are not allowed to round to the very, very, very end of the question. We would have to write out this whole crazy decimal right here, which I think is like 2 trillionths, right? When I don't want anything to do with that. So I'm just going to leave it as a sine of 91 until I finally do the calculation at the end. So just like we did before, when I cross multiply, it's F times the sine of 22 is equal to 6.74 times the sine of 91. I'll divide out by the sine of 22. Sine 22, running out of room. It's okay because this is it. So now I'm left with F, and it's equal to, you don't have to write this many times, but 6.74 times the sine of 91 over the sine of 22. So if I put that in my calculator, now you got to be careful. If this is an older version of the Inspire. This is like when I went to school, I used one like this. So it's been a little while, but I'm going to use parentheses. So if you're not doing the fraction bar, you're using parentheses. It's 6.74 times the sine of 91, close parentheses, twice, one for here, one for all the way at the beginning, divided by the sine of 22. That's why it's easier to use the fraction bar here. And I hit enter, and it gives me this length, 17, and it says nearest hundredth, so that would be 17.9. Remember, 100 has 2 zeros. I go to the second number. The number to this is 9, so it pushes that 8 up, and it becomes 99. There's many units, so we're okay here. And just to be certain, let's take our two calculations. 16.55 times the sine of 68 plus 6.74 times the sine of 23. And look at that, we're super close, okay? And that's kind of what we're looking for here. So just keep that in mind as you go along, that we're going down that road, all right? Those are our two different calculations. Okay, moving on to number 1. So in triangle ABC, angle A is 30, A is 12, B is 10. Find the sine of B to the nearest degree. Yeah, that should be find angle B to the nearest degree. If it's a sine, actually, I'll show you both. I'll show you sine of B, and I'll show you what angle B is, because it could ask for both. So just to be kind of clear here. So first things first, it's not a right triangle. Okay, I do not have any marked 90-degree angles, so I can't just do SOHCAHTOA. So that's out. So I have to use law of sines. I'm looking for the angle over here, and just like in the trig questions, if we were looking for a side, we cross multiplied. If I'm looking for an angle, I'm going to have to use the sine inverse here, okay? So keep that in mind as we work along. All right, so we have letters A and B, so it's the sine of A over A, and look at, even though it was over here, it's okay if you flip it, equals, and the other letter we used was B, so the sine of angle B over side B, which is always the side across, and so A is the sine of 30 over, and the side across from it was 12, equals the sine of B, which is what we don't know, so sine of B over lowercase b, which is 10. So we cross multiply, we get 10 times the sine of 30, which equals 12 times the sine of b. And we divide by 12. This is equal to the sine of b. Whatever you get when you type this in the calculator ends up being the sine of b. That's it. So if you do 10 sine 30, right, and divide it by 12, we end up getting 5 over 12. So this actually just equals, not 15, don't do that, 5 over 12. That's what sine of b is. It doesn't make sense that it asks for the nearest degree. If we're looking for angle b, remember we'd have to do the sine inverse of both sides. So the sine inverse of 5 over 12 is equal to the sine inverse of the sine of 12, or remember, or b. Remember also arc sine, kind of the same approach here. And then we're going to do second, we're going to turn the phone on, second sine 5 over 12. Okay, hit enter. And there's our lovely angle. Nearest degree would make it 25 degrees. And there's our nearest degree. So that's how you're working that one out, okay? Same thing here. So in right triangle PQR, so all right, Q is 90 degrees. Angle P is 57. Side P, so across from it, is 9.3, and find sine Q. Now, remember, one of the things we talked about was I do not want to use the sine of the right angle normally. So I don't want to do sine of 90 and then try to use that. So there's two ways to do this one. There's the law of sines. We can still use it. We can do the sine of Q over Q, side Q, equals the sine of angle P over side P across from it. And now I can just plug in and do work. So the sine of 90 over Q is equal to, and we get sine of 57 over P, and then I just cross multiply itself. Sorry, P is 9.3. So it's 9.3 times the sine of 90 equals the sine of 57. Now something kind of cool happens here. When you take the sine of 90 and put it in your calculator, you get 1. So this is actually just 9.3, okay? We left off Q. Oh man, what happened after we actually left off lowercase q? That should be the sine of 57 times lowercase q. There we go. Equals sine of 57 times lowercase q. I divide out the sine of 57, and that's my final answer. And look at this. This should look kind of familiar, because if another way to do this is to use trig. This is the opposite. That's the hypotenuse. I would just do sine of 57 equals the opposite, 9.3 over the hypotenuse q. I would cross multiply. 9.3 equals q times the sine of 57. And then I divide out by the sine of 57. And look at, we get the exact same thing. So the law of sines and SOHCAHTOA, when you're doing right triangles, is going to give you the same thing, and it better, because it has to work for this. So you can use either one. It's up to you. And we end up getting 11.08897. Nearest tenth, that would be 11.1. So right triangles, you can still use SOHCAHTOA. You can use law of sines. It's totally up to you. Non-right triangles, though, that's when you're going to have to start using this. All right, let's do a couple questions with some fire and lighthouses and fun stuff. So fire breaks out only 80 feet from the ranger's tower. The ranger needs to run water tower to open the tower spout so it will flood the area and put out the fire. How far is the run from his tower to the water tower to the nearest foot? So we're looking for this side right here. Okay. So if you look at it right now, we do have two angles and two sides, but the problem is they're not across from each other, right? So I have the 28 degree and the 80 here, and I have X, and I need this angle. And so we actually need to do a little bit of work first. We need to figure out this angle. And so what we'd have to do is take 46, 28, and add them, okay, get 74, and then take 180 and subtract that away, which will give us 106, a little bit better there, right? And so now that we have two sides and two angles across, now we can use the right triangle, or the law of sines. So we don't have any letters, so feel free to make them up. I'll call this A, I'll call this B, and this angle C. So I'm just going to do A over the sine of A, which is just like it was on the beginning of our paper. I'm going to do B, or just X, it's up to you, over the sine of B. And now I'll plug in. So A is 80 feet over the sine of A, which is the sine of 28, is equal to B, which we call X. You can leave it as B, but I'm going to use the variable that I introduced here, over the sine of 106. Cross multiply, so 80 times the sine of 106 is equal to X times the sine of 28. Divide out by the sine of 28. Remember, looking for a side, we cross multiply. All right, I typed it in my calculator, so parentheses 80 sine 108. And then I divide out by the sine of 28. I get 106, and it says nearest foot. The next number is a 0, so we're going to keep it. Sorry, it's 162.0. Doesn't matter what any of the numbers are after it. We're looking at just the tens placed around the whole number. So this is 162 feet, and that's what X is. All right? And that's how you answer that question. And that's it. That's all you're looking for. So keep that in mind as you go along. We'll try number 5, and then we'll wrap it up here. So 2 lighthouses are 30 miles apart on each side of the shoreline, runs north and south as shown. Each lighthouse spots a boat in a distance. One lighthouse notices the location of the boat is 40 degrees east of south. The other's lighthouse marks the boat 30 degrees west of south. So we have the 2 angles marked. They're 30 miles apart. What is the distance from the boat to each of the lighthouses at the time it was spotted? Round your answer to the nearest mile. So we're looking for these two. So first thing we need to know is we need to know the measure of these angles, right? I know this is 50. It's 40 and 50 make 90. This is 32. So 90 minus 32 is going to be 58. So I have the 2 measures of the angles. I can also get this. So I add these together, I get 108. That leaves 72 degrees here for this angle, and then we can just go to work. So if you want to call this A, B, C, because it doesn't have letters already, go for it. And so now we're just going to use the law of sines again. I have to do the law of sines twice here. Since this is not a right triangle, I'm going to need to figure out each side separately. So we'll do A first. So lowercase a, lowercase c. So it's the sine of A over A is equal to, there's B, the sine of B over B. We'll plug in, and this gets super repetitive, guys. Remember, math is all about patterns, and we're figuring out one right now, right? The sine of 50 over, don't know, is equal to the sine of 72 over 30. Cross multiply, divide out. So 30 times the sine of 50 equals A times the sine of 72. Divide by the sine of 72. And then A is equal to, we'll take and plug that into our calculator. So 30 times, and I may have to, one way you can also do this is do 30 sine of 50 first. Get an answer of 22 of that thing, and immediately take that answer and divide it by the sine of 72. And this will keep you from having that error. And I get 24.16 nearest mile, so that's just 24 miles. And so we want to do the same thing to the other one. Switch pens here. So let's go blue. And this time we're going to use still B and then C here. So we'll do sine of B over B is equal to the sine of, we need C this time over C. So the sine of 72 over 30. It wouldn't matter if you use 24. It would actually matter a little bit. we've rounded this answer, so we might get a little different answers if we used our answer from A here. So, but we take either one, because technically we're just following. If we're doing the math correctly, we're going to get correct answers for our work. So cross multiply. C times the sine of 72 is equal to 30 times the sine of 58 divided by the sine of 72. And C is equal to, and then we do our work here, right? So 30 sine 58, get that lovely number right there. Yep, took me for a minute there. And then we divide out by the sine of 72. We're at 26 point, get out of that, 0.75. Nearest mile, next number is a 7, we're going to round up, so that's 27 miles. And now we know how far apart the boat is from each lighthouse. So from lighthouse A, it is 27 miles, lighthouse C, it's 24 miles, and then so on and so forth. So that's it. I'll let you guys fill in this one. What conclusions can we draw? Well, let's just go through it. So the sine of A equals A over, and this is going to be the sine of C, so the sine of 90. Okay. Oh, sorry. This is actually just 1. Sine of 90 is 1, so that's 1. So it's equal to, sine of A is equal to, we cross multiply, we get A over C, which should make sense, right? Opposite over hypotenuse. Sine of B equals over B, sine of C, 90 over C. This is 1, and then this one is equal to B over C. And so once again, that's the opposite of hypotenuse. And what conclusions can we draw? If you guys can see that if it's a right triangle, the law of sines using the 90-degree angle is the same as SOHCAHTOA. That we did before. And that's it. All right. I'm going to leave you guys. Actually, we're going to do number 7 together. This is a really important question. Make sure you know how to do this when we go over the DBA tomorrow. So make sure you guys remember this one. Okay. So here we go. We got a boat, canoe approaching a lighthouse. The front of the canoe is 1.5 feet above the water, so this is important too. We talked about that before when we talked about the guy walking on his eyes from the other day. An observer in the lighthouse is 112 feet above the water, so not just 112, but all the way up and down. All right. At 5 o'clock, an observer in the lighthouse measured the angle of depression to the front of the canoe to be 6 degrees. Remember, this is 6 degrees, so is this right here. So when we go straight across, right above the canoe level here, all right, this is also 6 degrees, okay? So please keep that in mind. All right. 5 miles later, observe the depression of the canoe will be 49 degrees. So this is also 49 degrees there. All right. And once again, it's 1.5 meters off the part here. Determine state the nearest foot a minute, the average speed of its canoe traveled toward the lighthouse. So remember, speed is, I call it the dirt formula. Distance equals rate times time, D-E-R-T, dirt. So rate is the distance divided by the time. And that's what we're going to want to do to get our speed here. So first thing we need to do is figure out what these two distances are. So the distance from the canoe to the canoe, we'll call X. And then from the canoe here to the wall, we'll call Y. And we're going to add those two things together. That's what we need to figure out. Or can we just use this really big triangle here and just calculate this out? That would be another thing which would be great to do. So what can we do first? So we know that This is 112 feet from here to here. So we can use a little bit of trig to kind of help us out, because remember, this lighthouse is down and it goes down to there. So if I use this with my 6-degree angle, I should be able to figure out this whole entire line. This is usually one of the questions we have to do this twice, but it doesn't seem like it this time. So let's run with it. Here we go. So I have a 6-degree angle over here, my 49. Remember, these guys are all to the interior if we need it. We have this 112-degree lovely part right here. Actually, you know what we need to do? We actually do need to do 2 calculations here. So the first thing we need to do, we don't want to find x from here to here. But this is what we actually have to figure out. What we really need to do is figure out this distance and this whole distance and subtract them. And that's how we're going to get this. Or we can use the law of sines to figure this out. To do that, though, we need a side in this triangle first, right? We have to know one of them. And so you can either do, right, this distance first by using SOHCAHTOA in the small triangle here, okay? And then you can do this bigger triangle. We'll do purple because we already used blue here, right? This bigger triangle right there. So that's the game plan here. So if you're using a lot of sines, let's do the law of sines here. So we just talked about doing this. We'll do it 2 ways. All right, I'll do it 2 ways. The first way, I'm going to figure out first this. Why am I doing 2 y's? Z. Let's figure out this piece y. So in my 49-degree angle, this is the opposite side. This is the adjacent. So I'm going to do the tangent of 49 is equal to 112 over that piece right there we called y, and then we'll cross multiply this out. So y times the tangent of 49 is equal to 112. So divide out the tangent of 49. We're left with our answer. And we get 97.36. 0.11464. We don't want to round this yet. We're going to keep that. Now we got to do the whole thing, this whole z thing right here, okay? So the tangent of, and now we're doing this whole thing, so using this 6-degree angle, is equal to the opposite side, which is 112, over the adjacent, which is this side down here. So z, cross multiply again, z times the tangent of 6 is equal to 112. Same process, divided out by the tangent of 6, and we're left with that guy. 1065.608819. And so what we want to do is actually subtract these, right? So x is equal to y minus z. And so when I subtract, we're going to take that minus that out. 97 point. This is a little different calculator, so I can't just use what we're used to. And we did that backwards. Let's try that again. Awesome. And there you go, which is the same thing, just negative, but I want to make sure we got it right. And I get nearest foot per minute. So this is 900 68.2480754 feet, right? And it took them 5 minutes. At 5 o'clock, 5 minutes later, so we're going to do 968.2480754 divided by 5. That's the distance divided by the time. And so we get 193 foot per minute, feet, right? No, whoa, forget that, 194 feet per minute. And there's your answer, okay? If we were using the law of sines, what we'd really want to do is actually get this side first. So we would want to do sine of 49, opposite over 112 over that, and then cross multiply and solve. And then once we got this, we can do law of sines here and get that measure right there. That would be the other way to do this. This is probably the easiest for you guys to kind of go through. So that's it. Homework tonight, you can see right at the bottom of the paper, you guys are doing 1, 2, and then 3, 4, 5, and 6. We'll talk about the car question once again, angle of elevation of the ground, and then you should be able to go through and do this. So this is for homework tonight, and then you guys will have answers posted for tomorrow. All right, guys, let me know if you need anything else.